Okay, Victoria, I just happened to be in my office hour, so I've got all these tools here, and I'm recording this, but last time I tried to record such a thing, for some reason, Zoom did not make the recording available. So we'll see. At least I'll get an image. Ken does the job in 5 hours less time than Natasha. So since Ken's amount of time is with reference to Natasha's, we'll let X equal the amount of time it takes Natasha to do the job. X equals, let's do it this way. Amount of time it takes Natasha to do the job. And then Ken does it in 5 hours less time. So that's X minus 5. X minus 5 that's the amount of time it takes Ken to do the job. Okay, so let's see. They can do the job together they can do the job together in 6 hours. How long will it take each to do the job alone? Okay, so here's the thing. Here's a verbal model that the part of the job, just think about 1 hour, okay? So Natasha's going to work for 1 hour, Ken's going to work for 1 hour. They're going to get part of the whole job done in 1 hour. So the part of the job done by Natasha in 1 hour, 1 hour, however much that is, plus part of the job done by Ken in 1 hour, equals, it should be plus in the middle there, equals part of the job done by them together in 1 hour. Trivially true, okay? But that's going to be our key to getting an equation involving x that we can solve to answer this question. Okay, so let's take this verbal model and create that equation. The part of the job done by Natasha in 1 hour is 1 over x. Okay, so that's because the total time for job for Natasha, total time for Natasha and then if you ask what the part of job done in 1 hour, part done in 1 hour. Now we don't know either one of those things for her. But if she can do the job in, say, an hour, well, then part of the job done in 1 hour is the whole job. If it takes her 2 hours, then she can do half the job in 1 hour. If she can do the job, if it takes her 3 hours to do the job, so I'm running out of room here for my little table. If it takes her 3 hours to do the job, she can do, in 1 hour, she can do 1/3 of the job. If it takes her 4 hours to do the job by herself, it takes 1/4, she can do 1/4 of the job in 1 hour. Well, we don't know what it is, so let's call it X. Then she can do 1/X in 1 hour. So that's why it's 1/X. Basically, we took the reciprocal of the amount of time it takes her to do the job. For Ken, we do the same, and it's 1/X. 1/X minus 5. We just take the reciprocal. That's how much he can do in 1 hour. Together, they do the job in 6 hours, so together they can do the job in 1/6 of an hour. Now, we have to solve that equation, and if we solve it for X, then we'll know the value of X, the amount of time it takes Natasha to do the job. It's a rational equation, so of course we're going to multiply everything by the LCD. Okay, now LCD is, well, they're all prime. I mean, it's not like that X minus 5 has a factor of X. It's just a prime binomial. It cannot be factored. So basically, we're just going to multiply all three quantities together to get the LCD. 6, X, and X minus 5. Okay, so then multiplying all three things by the LCD, 6, X, X minus 5, 6, X, X minus 5. We're multiplying both sides by that LCD. Six X, X minus 5, then we're going to be able to clear out all the fractions. There's going to be cancellation, right? Because all this is over 1, same in the other two expressions. So we're going to go to Hacken on the 6's here. giving us x minus 5. Cancel factors of x minus 5, and we have 6x. Cancel factors of x, and we have 6 times the quantity, x minus 5. So we have to solve that equation for x. Well, that's an x squared right there. We distribute that x. So we're going to have to get everything on one side, because that's how we solve second degree or quadratic equations. Okay, so let's see. When we move everything to the other side, actually, let's figure out what those things are first. That's going to be a 6x minus 30. Six x minus 30 plus 6x equals x squared minus 5x. And now we're going to move everything to one side. I'll just move everything to the right side. Let's see, let's add the 30 to both sides and then do the rest of it in the next step. So add 30. Then we're going to combine those and call it 12x. 12x equals x squared minus 5x plus 30. Now we're going to add or subtract 12x from both sides. Subtract 12x from both sides. 0 equals x squared. Negative 5x minus 12x is a negative 17x plus 30. We can solve this by factoring. This is x minus 2, x minus 15. Yep. X equals 2 or x equals 15. Now we can reject the 15 because they can both do the job working together in 6 hours. Okay. If they work together in 6 hours, well, it could. Yeah. Yeah. Well, actually, we reject the 2. It couldn't be 2 because that she does the job working alone in 2 hours, because then it would take them less than 6 hours, take them less than 2 hours if she gets help from Ken. Okay, so she can do the job in 15 hours. And Ken can do the job in that number minus 5 hours. Okay, so Natasha can do it in 15 hours. Ken 15 minus 5, which equals 10 hours. Okay. Now, as a check, we might see, we might ask, is my answer reasonable in the problem situation? Okay, so for each 1 hour, on the first hour, you've got Natasha doing 1/15 of the job. And you've got Ken doing 1/10 of the job. So she's doing 2/15 of the job and he's doing 3/15 of the job. I'm sorry, she's doing 2/30 of the job. Because 1/15 is the same as the 2/30, and he's doing 3/30 of the job. Together they're doing 5/30 of the job, which is 1/6 of the job, which is what they're supposed to be doing together, if together they can do the job in 6 hours. So here's your answer to this working together problem.